Today, I'm Hongjing Xie, a PhD candidate in statistics from Mathematical Science Department in Michigan Tech. Today, we know that the journey of 1,000 miles begins with one step. So here, I'd like to get started with the first step with you all. Today's seminar will go through the R Studio installation, and after that, we will use R to do data analysis. We know that R is a tool for helping us do a lot of things like data analysis or the visualization. And after this, I hope you can have a feeling about R, a good feeling about R. Before we introduce this dataset, let's look at how to install R first. Then we will introduce the dataset after that, in case you don't remember it. Now let's look at this link. This is the link I shared with you before for installing RStudio. So after you get this link, you can scroll down till this. So we have different options like RStudio Desktop. This is free. For others, I didn't try this, and you don't have to try that. You only need to download the RStudio Desktop. Then you can click it. After you click it, it navigates us to this page. The first step is install R. So if you want to run a program software, you have to install R. If you want to run our program on RStudio, you have to install R, then install RStudio. Here, this is the hyperlink for installing R. If we click it, this is another link I shared with you before for installing R. That is not hard for installing R. Here, you can click the download R for, like, I'm using Windows. I can click the download R for Windows. Then it says that is what you want to install R for the first time. You can click install R for the first time. Then you can download the latest version. This is the latest version of R for Windows. Then you will click it. Then you will have this .exe file here. One second, showing folder. Okay, here it is. If we double click it or open it, we will have, one second, we have to wait for its response. Okay, do you want to allow this app to make changes to your device? We can click yes. After this, you can choose your language you prefer. Here we use English, then okay. Then it will have next. You can click all the next. It shows up the last step is install. After you click it, wait for a few minutes. It's usually less than 5 minutes. You will install it successfully. Okay, because I have already installed it, so I canceled the installing process here. Okay, this is for installing R. If you want to use RStudio, I prefer RStudio personally, because that is very friendly and nice to us, especially for beginners. If you input just the first letter or first few letters, it will give the candidate options for the commands. So you don't have to remember the all the commands exactly. If you know some of the the first few letters, then you input that. Then you can choose the one you want. Okay, for installing, download and install RStudio, it's almost the same with the with R, so I don't show it here. Okay, after we install R and RStudio, here I will use RStudio. We can use the search bar here, R. We have RStudio, then click it, then we can open RStudio. Here we have, as you can see, we have 3 windows. This is the console window, and here we have another window. It has the environment. That is the environment. It tells us what data set, what data values we have in this program. And this is history. It tells us what command you run before. And it also has tutorials. I usually look at the environment and the history when I run my program. And here we have the files. It tells what files you have. You can go to the files from this button and the plots. After we run the plot command in the source window, we will have the plots or the figure will be shown here. And we also have like different packages. And if you don't know one command, you can use like you can use help here. Like if we don't know the command MEAN or the plot, like this one, we can just input it and click enter. Then we will get the description and how to use it in here. Okay, now we know that we can run the code here. Like we have this print print 1. We can run command here, but we always want to, if we have a long program, we want to save it. So we want to write our program script. Now we click there, then we have this is the source window. We can run our program. We can code our program and run it from here. After we run each step or each piece, it will tell us what command or what step we submitted, and it shows the result here. And if we use plot command, then we have the figure. It will be shown here. Okay, now let's look at the data we want to use. Here is the data we want to use. That is called iris data. So for iris flower, it has different subspecies like iris setosa, iris versicolor, and iris virginica. In this data set, we have 100 samples. It means we have 100 flower samples. Then for this 150 flower samples, in the data, it shows in different rows. So each row represent one sample. Then then it also includes 4 features. These 4 features are the sepal length, sepal width, and the petal length, petal width. and 3 prediction labels. These 3 prediction labels are corresponding to these 3 iris flowers. These 3 iris flowers. So you will see that in the data set, you will see. Now let's look at the data. We have this data, the iris data. I use this data set because this data set that is pre-generated in R, so we don't have to use a file that is in my personal laptop, and it's hard for you to use it. Now let's look at this data set. So we have 150 rows in each row. Let's go to the top. Each row, we have 5 columns. Each row represents one sample flower, and it also includes 5 columns. The first 4 columns are the sepal length, sepal width, petal length, petal width, respectively. The last row is species. I think you can guess that it has 3 species. They are Setosa, virginica, and versicolor. So as you can see, it's hard to tell. It's hard to tell the different species just based on this. So we want to look at the summary of this data set in different ways. Like here, we can view it in table. This data set. This is the table view of the iris data set. Here it tells us, it shows the first 14 rows, or the first 14 samples out of 150 entries, or 150 samples, and 5 total columns. So we have 5 total columns, and if you put the cursor just on the column names, like sepal length, it will tell us that is numeric, and it range from 4 to 8. The first 4 variables or features are numeric. The last one is species. That is in fact form, and it has 3 levels. But we still, if we want to know these 3 levels, we have to scroll down. This is the Setosa, and fortunately, it ranges nicely, so we can tell the second one is versicolor. So this one is not nice enough. Now let's try to look at in a different way. Like, we know that they have the same format. We don't have to look. If we just want to look at the first few rows, we can use the head command of this data set, iris. Then we can see it outputs the first 6 rows of this data set. Or if you want, you can try this, the tail command. Then it tells us, it lists the last 6 or the last few rows, and we can see there are 150 samples or entries in total. If we want to know the more details about this data, like the structure of the data, we can use str structure of this data set. Here we have it tells us this data set, it is data frame. It includes 150 observations, or 150 observations, entries or rows, samples. They represent the same thing. This many 150 sample flowers, and of 5 variables. For these 5 variables, the first 4 are numeric. The last one is species. And it tells us that is factor with 3 levels, setosa, versicolor, but we cannot see the others, or the last one. It used dot to represent it. So if we want to know that, like, this is the structure of the data, we can use the summary as summary of this data. Then we can see that this for the it has 5 variables, or 5 for these 5 columns. The first 4 columns, they are numeric, so we can know their minimum value, the first quantile, the median, mean, third quantile, and maximum values for each column. And for the last one, that is a species, that column is species. For species, it has 3 levels. These 3 Aries flowers, setosa, versicolor, and virginica, they have for every of them has 50 samples. Okay, that is good. Okay, you might also want to know if the data is not is not in R. If you want to input the data from a different place, like from your own device, how do we input it? If you don't know the command, then you can use this way. We have the import dataset from. Okay, here I use from text because I saved that. Okay, let me use this first. You will see what is that. I put it in desktop. Seminar R. So I have this data. It is in .csv. It is .csv format. So I use the from text. Then I didn't click it. Okay, choose this data set and open. So we have different, like here, that is the input file. This is the output format. We'll have this is the name of the data. If you don't want to use the like IRIS, we already have this data. You can use a different, like IRIS. Maybe 1, or okay, let me use A. I just want to show you how to input the data from your own device. Then we have, like, if you want to include the heading, you select yes, and this is raw names. If you this is the default default setting for CSV file. We know the separate is comma. This is nice. And the last one, we know that the last row is spacious. So if you don't select this, your spacious might be like its tab will be a character. But if you want the string as factors, you can click this, then import. So here I don't if I don't click if I don't choose the string as a factor, I import it. Now it okay, here is the command for telling us how to read a file next time. Actually, if you if you this is the read.csv, and this part that is the working directory for this data set. It means it means the areas.csv, this CSV, this file, it is under this working directory. And now let's look at which working directory we are in. We can use get the working directory wd parentheses. Okay. This is the working directory I'm in. Now, if I want to change it to this working directory, like here. Okay, before I change the working directory, now let's try this one. If I just copy this, or you can use the arrow up sign on your computer. We can go up this one, and I don't want to run the view command. I can delete it, and I also don't want. Oops. That's too bad. It says you are screen sharing, so I cannot see it. Okay, let me just copy this and put it here. Okay, so here, if I don't tell it the working directory, this, then I delete it. If I run this, it will I will get error. It tell me cannot open this, no such file or directory. So if I use if I use the site working directory and double quotient, and I use this, copy and paste it here. Okay, then I run this. I run this command. Now my working directory is that file now, the seminar R. So now if I run this command, we can get the data. We can input the data successfully. So you have two ways for using the command to run it. The first one, actually I strongly recommend this way. You set the working directory first to the file you're working on, or your project, where's the location of your project. Then you can just read this file directly. Otherwise, you have to specify the these strings or this working directory always. Okay. This is the way how to input files. And if you want to save the files, you could use write.csv, and this is the data. Like here, you want to save, and this is the name. Like if I just say irisb.csv, then you will see a new file in a new datasets file in this under this working directory. Okay, run this. Okay, now let me check it. Now we have another file that is iris B, and that is created by this time. Okay, now let's go back to this. Okay, the next one I want to tell you how to install package, not the software, how to install package. For R, it includes a lot of packages. If you want to run something, you like complicated things. You don't have to always write the program yourself, like the mean, or that is like the mean. You can install and elaborate the package. Like I said, you have 2 steps to do it. Install. Okay, the first step is to install. It is installing the package. Now let's look at how to install a package. Install packages, and in the double quotient mark, we can install a package color space. This one, color space. I want to use color later. Now let's install it first. Okay, so here we install it successfully. For using this, we have to library this color. Okay, we have color space, so I don't have to spell all the word. Then we library this package. I forgot to tell you how to run the code and how to run the code. So it has 2 ways. The first way is we select it or highlight it, then click run, or we can just put it on this row, then it will run it up. Then we click run, it will run this piece of command, or this row or a few rows. And here it also tells us the shortcut, the keyboard shortcut for running a code. Code, it's Control plus Enter. So you also can do that. Okay, now I want to define a thing that is called. I want to use this color. My color here. My color rainbow. This. Okay, if I put use 3, it means I want to use 3 different colors. This, if I run it, then I run. Okay, now I selected it and Control Enter. Right, we have these 3 colors. You don't have to know what the colors exactly they are. We will see it later. And as you can see here, we have the RSA data, and we have the value. This is data set. This is value. My color. They are. This is the values of the color. And here is another command for if you have a lot of variables or data, you don't want to use it, you want to remove it. You can use this to clear the objects from the workspace. But if you click this, if you click this, it will remove all the data set, all the data, all the values you have. So here I just want to remove the RSA, this data set. This data set, I want to remove this. So I could use this command, remove command. Okay, so now we don't have the RSA data set. Okay, you might be curious about where is the ARIS data. It is not here. If you want to have the ARIS data, you can like use data, then IRIS, this data set. Okay, so before I click it, let's double check the environment window. Here we don't have the ARIS data. Now let me run it. So now we have the ARIS data set. Okay, now we know how to library how to install a package, how to install packages and library packages. You can try a different package. Okay, install packages. Let me check which packages I want to use. Plot tricks. Plot TRIX. We will use a package later. If you want, you can try to run it myself. You can try to run it yourself, because I have already installed these packages, and for large packages, it takes time to install it. So sometimes you don't want to run it again. You can use this is called hashtag, right? What? Okay. So here it means this command, this line, that is a comment. Even okay, let me highlight it and run it. It doesn't show anything. Actually, it didn't run if we have this sign. Okay, now let's library it. Okay. As you can see, it says warning message packages this was built under our version this. So warning message, it just tell you, it warn you the packages was built under this successfully. It's not an error, so don't worry about that. Now let's 1 second. Okay. Now let's look at others for this data set. Let me check. Okay, so here we can look at the box plot for different the box plot for different columns. Like I said before, the first 4 columns are numeric. The last column is factor. Actually, if you want to check it, you can check like the class of the ARIS data. Okay, here this means the ARIS data. In this we have the in the brackets we have 2 things. The first number represent the rows. The second number after the comma, it represents the column number. And if you like, let me try this first. If we have like comma, then 1, comma the second one, we don't give it a number, then it means we choose all of them. So here it means we want to get the first row of this data set. Now let's run it. We have the first row of this data set. Now if we use this -5, this means this means we use all the rows, and we choose all the rows, and this it is 5, but it says -5. -5 or -5, it means we don't show the we don't select the 5th row, well, the 5th column. We have 5 columns in total, so it will include the last column. Okay, for this one, if I want to look at the first few rows of this data set, we guess it will show the first few rows with the first 4 columns of the original ARIS dataset. Let's run it. So it has this first the first 6 samples, and the first 4 columns without the last column, which is species. Okay, now let's look at the last the class of the last row. If you remember, that is, if you remember the class of the ARIS, the last row of the ARIS data, it is factor. We know that from the structure, or from the structure command. If you don't know, if you didn't run it before, you can use this. It also says factor. So for box plot, we don't run for the factor. We don't run for factor variable. If you want to try it, you can try it. Now let's I want to plot the box plot. Box PL. Okay, the box plot. Now the data set I want to use is the ARIS data. Okay, now I want to choose the first 4 rows. This is one of way to choose the first 4 columns. Now I want to use a different way. It is from, okay, it means 1, 2, 4. So if we just run one, this is colon, right? 4, we have 1, 2, 3, 4. These 4 consecutive numbers. So it means we selected the first 4 columns. Now we run it. Okay, I want to use this bigger. Okay, so here we have this box plot. I won't explain how to explain the box plot here today, because we're focusing on the R code, and like they are gray colors. If you don't like this color, like before, we defined a color, my color, we can use this. The color, it has this one, it equals my color. Actually, here we have we have you can see that A shows. Let's run it first. Like this red color represent the sepal length. Then this color represent the sepal width. This color represent petal length. Then red color represents the petal width. Again, that is because for my color, in my color there are only 3 colors. If you want, you can use 4. Run it, then run this command again. So we have different colors for to represent different variables. Actually, there is another problem here. Like when we do data analysis, we have to know the meaning of each we have to know what data set we use. Here, the sepal length, that is the box. This is the box plot for this of sepal length for all of that 150 samples. It means this is the summary, the box plot for all the 3 iris flowers. If you don't want to, like, if you want to see this characteristic, you can run that. If you want to like run it like the box plot, it's just based on like the box plot is just for the data, the like for different species, we can run this. We have box plot. Then for the petal dot width, then we use the tilt. That means we want to draw the box plot just for the okay, I use the petal width, this one for different species. Then I use species as okay, I didn't have that. Now I'm gonna use like the iris. Like for this one, if we want to choose the last the species, so we could use $, then choose this species. Okay, now I don't want to use the color command, just use the original one. Oops. Petal width, not I didn't. Okay, IRI. Okay, now we have the box plot. We have the box plot for different for the petal width, and this is for the this is the petal width for setosa, the iris setosa. This is the box plot for the iris versicolor. You can see that the petal width setosa's petal width is smaller, is the smallest among these 3 iris flowers. The virginica, iris virginica is it has larger value of the petal width. So that's easier to explain the box plot. Okay, let me check my next. Okay, now let's draw the we looked at the first 4 columns. Next one we want to look at the 5th column, that is species. So for species, we want to look at like if you didn't look at the structure or the summary of that, actually we usually do that. But here I want to look at how many samples in different arrays data. I use the table array. Okay, I are this the last spaces. This one. Then we can see there are 50 samples for each arrays species. Then I want to assign this or define this as a new variable arrays. Excuse me, arrays dot table. This. Okay, here it means we assigned this to this new variable. If we run it, the next one we run the arrays table, then we'll get the same thing. So for this table, for this new variable, we can use it to draw the pie chart. It's just use pie chart, arrays table. Then we run it. We have this pie chart. We have this pie chart. If you don't if you think this pie chart is not fancy enough, you can use like the pie 3D. The pie 3D is in that Plotix this package plot 3D. Okay, this one. Arrays dot table. I didn't. Oh, maybe I forgot to elaborate. Plot 3D. Let me. Oh, not plot 3D. Sorry, it's called pie 3D. Pie 3D. Okay, so we have this. Like I said, if you don't like this color, you can use the color command. And if you want to put the labels and if you want to put labels on it, you also can do more things. Okay, so here I'm gonna copy and paste the command about pie 3D to show the fancy okay. Here is the command I pasted. So we have this. Here we have this pie chart, and if we run this, then pie 3D it has different arguments. This is the data set. This is the color. Explode. If you don't know the meaning of it, you can go help like pie 3D here. What's the meaning of explode? Explode, the amount to explode the pie in user units. After you read it, maybe you don't have intuitive if you still don't know that, we can try to let me put it. We can try to set it in different values. Like if we set it as, let me use a big value, 0.3, then you can observe, you can pay attention to this figure. I'm gonna run it. Okay, run it. So it explodes bigger. Okay, next one, like we didn't have the here we didn't have the title of this figure, this mean equals, we put a title, we set a title for this, for this pie chart, and okay, that's all for that. This is for the pie labels. We have, okay, I haven't run it. Let me run it. We have Setosa, versicolor, and virginica. Please pay attention to the order of these three things. It should have the same, like, it has the same order with the colors. Now let's run this one. So this pie slice represent the versicolor, and this represented the Setosa, and this represented the virginica. I tell you this because I want you to know that if you like the original version, like the sample is the version of like the pie or the pie chart, you can use that. Actually, you always can draw fancy figure, the fancy visualization of the data. If you want to try that, you can discover that yourself. This is just for sparkling the idea. Okay, next one, we want to look at the histogram. Okay, we can look at histogram. This is the histogram of the for drawing histogram. For this one, we want to okay, if we just just input this IRIS. I do have this. Okay, it says X must be numeric. So we know that the last this is an error, not a warning. So we don't have a histogram for the iris data. So we want to fix this. We want to fix this problem. For fixing this problem, we can look at this. X means the argument. This must be numeric. We know that the last column is not numeric. Then we can try to delete it. Then it still say it must be numeric. Then we can guess that is not the that is not the the last column is not the reason for this. Actually, here the histogram, we can help hist here. This is hist. Then we have the X. It says a vector of values for which the histogram is desired. So we should input a vector. Actually, this, like, as you know, it is a matrix, or it's not a vector. If you want to double check it, we can use class CLASS. This for checking. It's a data frame. It's not a vector. So if we want to use a vector, we can choose just one of the column, like the first column, that is a vector. Then we can get we can get the histogram for the first column. As you can see, hist of something, the x-axis is the something we imported, and this is histogram of that. If you want, you can use the $sign. We set the first one, right? We want to compare this. Then if you run it, we have, this is the the histogram of iris, $sign, then sample length. this is also that if you want to edit the histogram, if you want to edit the histogram, make it fancier, we can try to do that later. Okay, before we go further, like we use the histogram of the areas data without the last column, because we want to have the histogram for all of these, not all of these 4 features: sepal length, sepal width, and the petal length, petal width. So how do we do that? One of the way is you can just you can copy, paste it, and just change this. Let me, okay, $. Then the next one. Okay, so now we have this, but you might want to put them in the same figure, like all of them here, and put them in, like we split this this canvas into 4 pieces. Then we can use the par command, mf rule. Okay, here it means I want to split this window or this canvas into 2 rows and 2 columns. Then we run it, and this one. Okay, let me run this. I don't want to put more things again. Now let's, okay, but here, actually we're repeating doing the same thing just for different columns, right? Then we can use that. Okay. Then we can use apply command. Apply command. The array, that is the data we want to use, that is areas data, and we don't want to use the last row. And margin, the margin, we can use 1 or 2. 1 means we use this data, where apply, where if we use the 1 represent a row, 2 represent a column, here we want to draw the okay, this is the command or the function we want to run for this data. Actually, we want to apply this function on each column to represent the column, each column of that. Now we can, okay, let me try to click this, clear this, then you will see you will, okay. Oops, what's did I? Oh, I think. Okay, I have to run the par command first. Then I will draw all of these 4 histograms, of all of these 4 histograms in the same window. Like as you can see, actually we had 4 histograms, but they are on different canvas. Now they are on the same canvas, but they are on the same canvas, and each of them has the same space or same room in that canvas, in this canvas. Okay, now let's focus on one of the histogram, and it's kind of exercise. Like we know oops. Okay, so here I have to, if I want to go back to the whole one canvas, then I can use the DE device of then I run this. So I don't have this. I don't have the split it canvas or split the window. Now if I run it, I have this histogram on the on this canvas. Then let's look at the axis and the mean or different things you want to have or you want to include. The x-axis, the horizontal axis, it is the $. If you don't want to use this, okay, let me copy and paste. Okay, so here we have this is the command for the name of the horizontal axis, and for the vertical axis, that is good. It's just a frequency, and this like we use the main command before already. This is the name of the the title of this histogram. And the breaks, if you don't know what is that, you can use the help. Okay, you can use help, then do that, or you can use, like we are using the you also can use the question mark, then the command hist. When you run it, like this page was refreshed, so you also can use that. You also can use question mark to look for to ask for help. Now let's go back to here. Then the frequency, if you use true, it means the vertical axis is frequency, and the labels, we also have the labels, and okay, suppose we don't have this. Okay, now let's just run it. You will know all of that. We can compare this figure and this figure. Like this figure, we have the x-axis, sample length, frequency is default, and we also have the title of this histogram, that is histogram of sample dot length. And the breaks, if you want to try, okay, we will try this later. Frequency true, it means we have, like, this is the number of 5. For this one, it's easy to tell. This one, like, if we don't have the labels, it's kind of hard to tell. That is like 27 or 28. So you can put the labels on the different bars, on each bars. As you can see, we can now see the whole number of the whole labels of these two bars. Excuse me. The reason is, I think the reason is the range of the frequency, or the range of the y-axis is too small. So we can set the range of, oops. Okay, let me just input value. Okay, it means the range of y, see, 0, 30. Okay, now it is 30. This is 30. This is a little bigger than 30. We can use like 33 or 35. Okay, I prefer 35. Then I rerun it. I believe I can see these two whole numbers later. Then we also want to check the different. We also want to check this, right? This is 10. What if we use 20? Let's try it. Okay, here is the histogram for this. Then we can see that, okay, actually for this one, we have different things to different solutions to address the problem. Here, if we use breaks 20, then this it means we have more breaks. We just break the range into smaller, into more pieces of sub intervals. And if we have more sub intervals, then every sub intervals frequency is no greater than the previous one. If we still use 10, I want to show you that if we still use 10, then we can see this is 30, this is 31. We can see these two numbers. Okay, the next thing I want to say is like how to save the figure. If you don't want to run the command, you can here you can just use this. We have export. You click the export, you can save it as image, you can save it as PDF, and you also can copy to clipboard here. Then you can copy it, you can copy the plot. You also can change the measures like the width or the height and the width, the height of this figure. And if you want to maintain the aspect ratio, you can choose this and copy it and paste it on the like Word or some or other place you want to paste. Okay, save as. If we save as image, then you can choose the image format. It has different formats into the directory. Like here, that is the desktop seminar R because I cited it before, right? I cite the working set WD. That's why. So this is the default working directory for saving, data sets, data sets, figures, and figures, and you also can choose that. Then just click save it. Okay, no, I don't want to save it. If you want, you can try it later. Okay, I think I used too much time to talk about it. This is simple things. Now let's copy paste other. Okay, here I just want to quickly go through other things I prepared for this seminar. We can do. Okay, we were on 30, like here. This is the pairwise scatter plot. If we want to look at the relation between, each two pairs of the first four features, we can use the pairs command. Then we have this. As you can see, this figure, this plot, this scatter plot, and this one, they are symmetric. We don't. Okay, they are symmetric. We don't want to. If we don't want to show the lower panel of it, we can use this lower panel. Now, then it will show that. Let's try it. I also use my color. That is not okay. This my color is not nice either. But you can try to use different colors. Later, the color you can choose the color you like. Yes. And so here we have different colors to represent different species. Actually, we have three. We have three colors, right? And if we want to use the legend to legend, to tell us what different colors represent, then we can add legend on that species labels. Okay, I don't have species labels. Species labels. I have that. New species labels. That is the last row of the ARIS data. ARIS data, the last row, fifth row. That column. I said wrong. Okay, then I run it. Okay, so here we have that the red color represent setosa, the green color represent the versicolor, and and this is the virginica. Like I said, if you want, you can run the device. We can close this device. Okay, let me just quickly run this. Iris. Iris, where is that? I didn't define that. Iris one, I think that is the first 4 columns of the data. I hope this. Okay, now we have it. The like different colors represent different species of the iris flower. You can actually you can see that the red one represents the setosa. I think it's easier to distinguish it from the other 2 flowers, especially for these 2, the petal length and the petal width. Its values is significant less than the other 2 flowers, the other 2 species of iris. Here I want to show the clustering method, like the hierarchical clusters and the k-means. For these 2 different clustering methods, we can group the 150 samples into different groups. Let's run this first. Oops, Iris. Okay, let me define that first. Iris 1, that is the data, the first row of 4 columns of the data. So we have, this is the distance between the pairs of the first 4 columns, and we use the hierarchical. This is the command for hierarchical clusters. So even though even you don't know the hierarchical, like how do we do that in theoretically, but you know how to use the you can use the package or the command to run it to get the result you want. Now we have the hierarchical clusters. We want to plot it. So here it means okay. So here it means we can group all the samples into here it is into, if we cut it here, it means we group it in 2 groups. But we know that we group that into 3 groups. Actually, we can we were in the gut view, we know there are 3 species, 3 groups. We can cut it between here. Like if we draw a line here, we know it splits or it groups into 3 clusters. This cluster this cluster include this many samples. Actually, each line represent the different lines represent different samples. And this one, this is the second group, this is the third group. Now let's look at the details about the the details about the clusters, like which sample grouped into the first cluster, which sample grouped into the second cluster. We know that here k equals 3, it means we group it into 3 subgroups, then 3 clusters. If we run it, and if you want, you can see this. This means these samples group into the first cluster. 2, it means they are in the second cluster. We know that the first 50 samples, they are the same. They are setosa, right? And we can see they are all setosa. That is good. But now let's look at the second one. The 51 to 100 samples. We know that they all should be 2 or 3. Actually, it's up to the first sample, like the 51. It groups into 2, and others, they are grouped into 3. We know that this many samples, the hierarchical cluster method cannot group them into the correct clusters 100% correctly. And next one is like this. If you want to check the false discovery rate, this is the command I wrote myself. I don't run it here. And the last one is the k-means method. K-means method for grouping this data, it is better. Now let's look at this. I define a new define errors data into a new thing because I don't want the species. I don't have I assign it as now. I don't have that. Then I use this. The k-means for this new data, I in the gut view, we know we have three arrays species. This we set it 3. Actually, if you don't know the data, and if you don't know the data, you have to try different values of the number of clusters, and to check which one has the best performance. Okay, next one, people. Okay, so here we can see that setosa, 50 of them. That is great. 50 of the samples, they are setosa, and they classified as setosa. Versicolor, 50 of them are versicolor, but only 48 of them assigned as versicolor, and 2 of them assigned as virginica. So that is not perfect, but it is better than. Let me run this. Okay. Here there are 20. There are for hierarchical cluster. For hierarchical cluster methods, there are 24. There are 24 samples grouped into the wrong the wrong clusters, or the wrong species. But here we can see that there are 16 of them. We cannot group them. We cannot group them 100 exactly correct. But this method, this is one of the metrics we can check, the false discovery number. This is 2 plus 14, that is 16. This is 24. The wrong classification for 16 is less than 24. It means that is better. If you want to see it in figure, you can draw it. I believe these 3. I use this symbol as okay. This the green represent the versicolor, so it's easier to distinguish to be distinguished from other two Aries species. This is the center of the k-means. There's three species. Okay, that's all I want to say about using R for data analysis for today's seminar. Then let's go back to that. And yes, this is what I wanted to say. This is just the tip of the iceberg. If you want to go deeper, you can that is better if you have a project. Based on that project, you have different goals. For different goals, you have to do different things. Then you can use R to do that. You can use R to do that. If you don't know that, you can use Google, or you can use the help command, the help documentation in R. And I hope you now feel confident to start exploring R yourself. Like you have you have got the first step, right? Good luck for your journey of R. That's okay. That concludes today's seminar. Thank you.